When aligning a K-Tech unit with stance control, the load line must pass through or slightly behind the knee center. This is essential to the function of the position-activated stance mechanism. The load line must never be in front of the knee center. If the load line is in front of the knee center, the amputee must transfer his weight to the sound side to initiate flexion, and the unit will not release from stance phase. The same alignment used in the K-Tech stance control unit is also used when aligning a swing control unit in conjunction with the Endolite ESK. The Endolite ESK with weight-activated locking requires the load line to be slightly behind the knee center for correct knee function. When aligning a single-access knee for use with a K-Tech swing phase only unit, the load line should now pass in front of the knee for alignment stability. The stance adjustment screw controls the yield rate when the stance phase is active. It has no effect on the swing phase. Depending on the patient's size and weight, a faster or slower yield rate can be achieved. In general, the heavier the patient, the higher the resistance. When the stance adjustment screw is in the fully clockwise position, stance resistance is maximum. By turning the adjustment screw 1/2 turn counterclockwise, the stance resistance is at the minimum setting. It is important not to exceed the 1/2 turn counterclockwise adjustment. This could result in the unit not releasing from stance properly. The stance resistance should be adjusted while the patient is wearing the prosthesis. One effective method of determining the amount of stance resistance that is correct for the patient is to have the patient sit down in a chair, using the stance resistance to support his weight as he descends. Too much resistance, and the patient will have the feeling of waiting for the limb to let him down. Too little resistance, and he will have the feeling the limb will not support him. With the proper setting, a smooth, controlled descent is possible. Later, if the patient chooses to sit down faster, he can eliminate the stance by pressing the stump back and then sitting down using a jackknife technique. You will see later in this video these same techniques can be used in descending stairs and ramps. It is not recommended that the patient lift the prosthesis when sitting down. After you have determined a satisfactory stance resistance setting, you should proceed with swing phase adjustments. First, with the patient standing between parallel bars, hyperextend the knee and raise the selector switch. This eliminates the stance feature and allows you to concentrate on the swing phase only. You should caution your patient that the stance resistance has been eliminated and the limb may have a tendency to buckle at heel strike. Next, we suggest starting with a flexion resistance setting of 4 and extension resistance set on 1. This is accomplished by first turning the flexion adjustment cap counterclockwise until the number 1 on the flexion cap is above the indicator mark, and the indicator mark is directly above the number 1 on the extension label. Turn the flexion adjustment cap clockwise until the number 4 is directly above the indicator mark. Now, have the patient walk normally in the parallels and observe the amount of heel rise on the prosthetic side. If the heel rise is excessive, increase the flexion resistance until the desired effect is achieved. This is accomplished by turning the flexion cap clockwise. If heel rise is too little, reduce the amount of flexion resistance by turning the flexion cap counterclockwise. Ideally, the heel rise on the prosthetic side should match the heel rise on the sound side. Once you have the proper flexion resistance setting, check to see if the limb is coming forward too quickly. If this is the case, you now need to adjust the extension resistance by first, recording the flexion resistance setting for later reference. Now turn the flexion cap clockwise until the indicator mark begins to move in the clockwise direction. After increasing the extension resistance, turn the flexion to the previously recorded position over the indicator mark by turning the cap counterclockwise. Walk your patient to determine if additional extension resistance is necessary. If so, repeat the previous procedure. If the extension resistance is too high, turn the flexion cap counterclockwise until the indicator mark is over the desired extension position. Then, return the flexion cap to its recorded position by turning the cap clockwise. Once you have achieved a satisfactory gait for swing phase, return the selector switch to the down position and walk the patient in the parallel bars. The patient should be instructed that he must initiate flexion while he has weight on the prosthesis. If he transfers his weight to the sound side before initiating flexion, the unit will not release from stance. In order to eliminate the stance resistance, a hyperextension moment around the knee must be present. This occurs automatically just before toe-off in the gait cycle. This feature is beneficial should the patient stumble. The unit will partially support his weight and allow him the opportunity to recover in many instances. The patient should be shown that he may voluntarily eliminate the stance for one cycle by pressing the stump back and then immediately forward. This is useful if he encounters terrain where ball pressure does not occur naturally, such as soft sand or uneven ground. In addition to using the stance feature of the unit as an aid in sitting down, it is also useful for descending stairs and ramps. If the patient encounters a steep ramp and at heel strike he does not press the stump backwards, he can use the stance feature to descend in a controlled manner. This is also true with stairs. If he is instructed to place the heel of the prosthetic foot on the edge of the step and not press the stump back, he can learn to descend stairs step over step. If the patient presses the stump back, he can descend the stairs in a jackknife technique. The unit can also be put into a lock mode. This feature is useful for activities such as standing for a long period of time at a workbench. To put the unit into full lock, flex the knee slightly by having the patient place the prosthesis in front of him and raise the selector switch. The unit can be locked at any angle of flexion. The unit is locked against flexion, but can be extended to the desired position. To release the lock, simply lower the selector switch. The last feature of the K-Stance hydraulic knee control is the ability to eliminate the stance feature. This is useful for certain activities, such as bicycling and other activities where the stance feature might create difficulties. The patient should be reminded that when the stance is eliminated, the unit is free to buckle at heel strike. To remove the stance feature, simply have the patient hyperextend the knee by putting the prosthesis behind him and apply weight to the ball of the prosthetic foot. With the load on the prosthesis, raise the selector switch. The unit is now equivalent to a swing control unit. Noises are a common occurrence in a prosthesis. There are many attachment points where various components come together. All of these points are areas to check when attempting to eliminate noise. When checking the hydraulic unit for noise, a common suspicion is the noise made by the stance valve closing. If the patient takes his weight off the prosthesis and moves the limb back and forth, a slight click will be heard. This is not an area to be concerned with. During normal walking, the stance valve is blocked in the open position and no noise will occur. The more